Assalamualaikum warahmatullahi wabarakatuh to Dr. Zamir and all my fellow friends. So today I will present the crystalline silicon solar cell. Introduction. Solar cell is the PV cell that converts solar energy into electricity. It uses semiconductors to interact with the incoming photons from the sun. There are two types of crystalline silicon solar cell, monocrystalline solar cell and polycrystalline silicon solar cell. Monocrystalline silicon solar cell is from the thin wafers of silicon cut from a single crystal, whereas the polycrystalline silicon solar cell we got from wafer when we cut wafer from a block of silicon crystal made up of many crystals. Polycrystalline silicon solar cell has better temperature coefficient, but the monocrystalline silicon is the most efficient solar cell in terms of energy generation. Device configuration. Solar panel. Solar panel has 6 main components with the aluminum frame at the top, and then we have tempered glass, EVA, solar cells, EVA again, backsheet, and lastly the junction box. Solar cells. The solar cells, the performance of solar cells is determined by the type and characteristic of silicon used. There are different additives such as boron to create N-type silicon and phosphorus to create P-type silicon. The electrical contacts which interconnect the cells are known as bus bars and allow the current to flow through all the cells in a circuit. Next, we go to the glass. The glass is used to protect the PV cells from weather and impact from hail or airborne debris. High-strength tempered glass is around 3 to 4 mm thick. The tempered glass is designed to resist mechanical loads and extreme temperature change. The glass also have high transmission. The high transmissive glass is used to improve efficiency and performance of solar cell. At the top of solar panel, we have aluminum frame. This aluminum frame is used to protect the edge of laminate section housing the cells. The aluminum provide a cell structure to mount the solar panel in position. The aluminum also extremely lightweight, stiff and able to withstand extreme stress and loading from high wind and external forces. This aluminum frame is actually depending on the panel manufacturer. Next is EVA film. In solar panel, we have two layers of EVA film. One is above the solar cell and another one is the bottom of the solar cell. EVA is the ethylene vinyl acetate. It is polymer highly transparent layer. EVA film is used to encapsulate the cells and hold them in position during manufacture. The importance of EVA film The EVA film is important for the long-term performance by preventing moisture and dirt ingress. EVA film also extremely durable and tolerant of extreme temperature and humidity. EVA film also provides shock absorption, so it protects the cells and interconnecting wires from vibrations. Then the backsheet. The backsheet is the moisture barrier and final external skin. The backsheet provides both mechanical protection and electrical insulation. The backsheet, made of various polymers such as PP or PET or PVC, which offer different levels of protection, thermal stability, and long-term UV resistance. Instead of using the backsheet, other manufacturers also use the dual glass panels. The dual glass panels is the real side glass that is more durable and longer lasting than backsheet materials. And then at the bottom of solar panel we have junction box and connectors. It is small with a proof enclosed located on the rear side of panel. It is securely attached the cables required to interconnect the panels. It is central points where all the cells sets interconnect and must be protected from moisture and dirt. Next, we go to the design of solar cell. In order to get better performance of solar cells, we need to count to these four parameters: surface reflections, carrier collection, recombination, and parasitic resistance. So next, we go to the operating principle. So basically, operating principle tells us how does it works. So, in solar cells, when the solar cell is exposed to sunlight, the process that generates voltage or electric current in PV cells is called photovoltaic effect. The solar cells are composed into solar cells are composed of two different types of semiconductor, P-type and N-types, that are joined together to create a PN junction. By joining these two types of semiconductors, an electric field is formed in the region of the junction as electrons move to the positive p sides and holes move to the negative n side. The light wave knocks an electron off a silicon atom, setting the electron loose and leaving electron loose and leaving the positive charge. Next, the loose electron then moves towards the top and reaches the n-type layer, which readily accepts the electron. Here, this happens because the energy from the photon causing it to jump into the conduction band. Similarly, the loose hole moves toward the bottom and reaches the p-type layer, which readily accepts holes. In the excited state in the conduction band, these electrons are free to move through the material. This field causes a negatively charged particle to move in one direction and positively charged particles in another direction. In other words, they are separated. Next, the connecting wire between the top and bottom metal electrodes provides a pathway for the electrons to move towards the holes. Then, the flow of electrons is electrical currents. This continues as long as sunlight shines on the solar cell. We can see in the image below where the current flow opposite direction with the electron flow. In fact, one solar cell produces several watts of power. So in order to apply this solar cell for any devices which use more 1000 watts, we need several solar cells to wire together to make a solar panel. And the last part is the application of device. Solar energy is a good alternative to replace fossil fuel as the major energy source because the solar power is renewable at absolutely no cost to supply energy infinitely. So there are many applications we can use with the solar energy. Firstly, the calculator, and then the remote lighting system, water pumping, water treatment, solar portable power supply, and the satellites. So that's all from me. Thank you.